Hello and welcome to Science Talk. I am your host, Jim Massa. In this video, I wish to discuss with you some findings from the world of climate science. And I'm going to start off with this report on involving Antarctica. For many years, it's been a mystery or a puzzle as to why does Antarctica not seem to warm as fast as the Arctic. Well, there's a couple things to keep in mind. First of all, Antarctica, when it is pointed away from the sun, that is its winter, it is actually further from the sun than the northern hemisphere is when we're having our winter. So, and right now Antarctica is having, it's the equivalent to their summertime, as in the northern hemisphere we're having wintertime as I speak to you now. So when you're further away and pointed away, receiving less sunlight, less sun energy, that will tend to keep things cooler. As less solar radiation reaches the surface. But very basically, the answer turned out to be rather straightforward. Antarctica is higher elevation. So a new study that was published in the Earth System Dynamics Journal shows that basically the elevation of Antarctica, because it's higher, less solar radiation reaches the surface, it doesn't warm as rapidly, say, up in the Arctic. Because we know that generally speaking, temperatures decrease with an increase in elevation. Now, the average elevation of Antarctica is 2,500 meters. Okay? That's roughly 7,500 feet, a little more than that, but it gives you an idea of it. So, the Arctic itself is warming at a rate twice as fast as the rest of the planet. Okay? Now, the lead author on this study was a gentleman named by Mark Salzman. He's a researcher at the Institute for Meteorology at the University of Leipzig in Germany. He was the lead author. He says, on average, warming for the entire Antarctic continent has been much slower than the Arctic warming so far. And what he did was he did a very interesting modeling experiment. He then say, okay, let's model the Antarctic system if we bring the elevation down to basically sea level. And what he found was that at that point in the modeling, granted this is a model, computer model, that in those model conditions, Antarctica warms at the same rate, or slightly less, but definitely closer to the rate that the Arctic is warming. So, so it's very interesting that sometimes really the simple solution is often the one that's the case. But keep in mind there are some differences between the Antarctic region and the Arctic region. Antarctica is a landmass surrounded by ocean, whereas the Arctic is an ocean basically surrounded by landmass. So that gives you different physical properties. And I'll be talking more about that, some of those differences later on in this video. So I found that to be an interesting. On a note that's of little more concern, or should be of concern for us, is studies are showing now that a melting Arctic, a thawing Arctic, is increasing the release of nitrous oxide. Okay. Nitrous oxide is considered a so-called minor greenhouse gas, but it actually is 300 times more potent than CO2. Carbon dioxide. A lot of nitrous oxide is stored in the permafrost. With a warming Arctic, the permafrost is thawing. Now the correct term to say is thawing, not melting, because melting implies the change of physical state from ice to liquid. We simply have frozen ground, and the frozen ground is thawing, becoming not frozen. So it's more technically correct to say that the permafrost is thawing. Putting that aside, a thawing permafrost will release nitrous oxide, releases CO2, releases methane. So before, where the Arctic region the boreal forest, which rings the planet pretty much at about 60 degrees north latitude, from through Canada to Yukon, all the way around into Scandinavia, Russia, and so on, is probably the largest, most continuous land ecosystem on the planet. There's a lot of stored material there. So adding to the issues, the Arctic, which used to be a carbon sink, that is, the carbon is sequestered, removed from the environment, is now becoming a carbon source, meaning it is adding to the environment. One of the reasons why the Arctic region is warming faster than the rest of the planet. As you continually heat up the Arctic, you continually increase the rate of thawing, increasing the rate of CO2 and methane and nitrous oxide being released into the atmosphere. These trap the heat, further increasing the temperature, further increasing the thawing rate, further increasing the releasing rate, etc., etc. So, in a study where the lead scientist was Caroline Voigt from the University of Eastern Finland, she reported in the study that's published in the Proceedings of the National Academy of Sciences, she reported this increase of nitrous oxide being released. Related to the increasing thawing of the permafrost, Igor Semeletov, who is a researcher at the International Arctic Research Center located at the University of Alaska Fairbanks, he has done some superb research. He and his wife Natalia have done superb research into the releasing of methane from the permafrost. They have traveled all throughout Alaska, Canada, Russia, and so forth, documenting and measuring the increased release of methane. This is actually what really concerns climate scientists, is the methane question. Basically, how much is there and at what rate is it being released? Researchers from Norway have documented methane bubbling out of the ocean floor. In the ocean floors at high latitudes, like the Arctic Ocean, there are found frozen methane hydrates. Basically, it's a methane water complex, and it's frozen. But when you start warming the Arctic, and the ocean floor and the water, these start to expand, and then they start to melt and dissolve and so forth. And we are now seeing, in significant amounts, this methane being released, which will eventually make its way into the atmosphere. Continuing on, another update on climate news. Half a degree warmer means a lot. The target goal from the Paris summit was to keep the warming to 2 degrees centigrade or less. Well, researcher Peter Fleiterer, who is a scientist with the Potsdam Institute for Climate Impact Research and for Climate Analytics, Potsdam Institute located in Germany, has basically shown that if humans can keep the warming to 1.5 degrees centigrade warmer than 2, that half a degree, though may not sound like much, is critically important. Basically, because from the start of the Industrial Revolution, we can actually measure as to when the increase of CO2 into the atmosphere began. Around the start of the Industrial Revolution, it was about 280 parts per million. It is now consistently above 400. And as I will discuss in another video with you, we have a direct correlation with CO2 levels and temperature. They're directly related. Increase the level of CO2, temperatures go up. Decrease the level of CO2, temperatures go down. There's no denying this. The evidence is quite clear on this based on ice cores and other sedimentary analyses. So if humans if we were to stop burning CO2 right now, burning fossil fuels right now, releasing CO2, the damage is still done. It's a matter of how much can we mitigate it. So his studies have shown the benefits of trying to minimize how much warming that takes place. Okay. Continuing on, my next update on climate news. Climate change can cause killer heat waves. Researchers have established a direct link between global warming and heat-related deaths from extreme heat waves. Here's that 0.5 degree Celsius coming into play again. A tiny rise of 0.5 C in mean summer temperatures in India, and for that matter, other tropical located places such as Southeast Asia, Thailand, Myanmar, Laos, and so forth, will result in a 146% rise in mass death from the extra heat. Think about that. Raising it 0.5 degree C. That's basically, 1 degree C is about 1.8 degrees Fahrenheit. So we're basically talking 0.9 degrees Fahrenheit increase. Raise the temperature that much and you increase the death rate from heat waves 146%. That is extremely significant and extremely telling. Researcher Amir Agakuchak, a civil and environmental engineer at the University of California, Irvine, is the one who reports this. He's showing that average temperature is increasing in the Asian subcontinent, the Middle East, and Africa. The projections based on her research could be at least 2.2 degrees C and maybe as high as 5.5 degrees Celsius. They report their findings in the journal Science Advances. They also looked at the meteorological evidence from the years 1960 to 2009, and in that they're showing that the temperatures, mean summer temperatures, went from 27 degrees C to 27.5 degrees C. If that happens, the probability of a heat wave killing more than 100 people grew from 13% to 32%. The devastating extreme in heat in mainland Southeast Asia, also Thailand, Laos, Myanmar, Cambodia, Malaysia, could be blamed on a combination of global warming and El Nino. Now, El Nino is also called ENSO, El Nino Southern Oscillation. That is a weather system that basically is global in nature, and it has to do with the location of a low pressure system located over Indonesia that tends to move eastward and westward, back and forth, oscillating over a 7 to 10 year cycle, and with that can cause changes in local conditions. So when scientists are doing their studies, they have to factor this in. So they have to remove that signal from the data analysis. And in the computer modelings, they do that. They'll run computer modelings where they include the ENSO effects and others where the ENSO effects are removed, and then look at what the results of such modeling indicate. Lots of times, a El Nino may be good for one region of the planet, but create problems for another region. And conversely, the flip of it being La Nina can also be good for some parts of the planet, not so good for other parts of the planet. Continuing on with discussing the results from heat waves. Heat waves will menace most of the planet by 2100. To the point that if countries continue burning fossil fuels at the current rate of usage, 3 out of 4 people will be at risk from lethal heat waves. 75%. Why is that? As temperature rise, heat and humidity begin to take a taxing toll on human physiology. Humans are adapted to body temperatures at around 37 degrees C. That's basically that's 98.6 on Fahrenheit. That's our typical body temperature. Humidity, which is of course the levels of water vapor in the air. Humidity, warmer air has a better capacity of holding more moisture to a point. Okay. What happens is, in extreme heat, we perspire. And the heat, through evaporative cooling, the perspiration evaporates off our skin, and that helps cool our bodies. But up to a point, and the threshold temperature is around 31 degrees Celsius, at that point there, perspiration does not evaporate, making for a very uncomfortable condition, but also putting taxing situation on the body. The body core temperature, because it's not cooling, body core temperatures start to increase. That can lead, if you lead to fevers, you can then get protein degradation, coronary issues, heart attacks, kidney shutdown, etc. So higher temperatures is not good for humans. And as it is, there is talk that the Middle East region could become completely uninhabitable by 2050, 2060 because of the extreme heat, reaching over 135 degrees Fahrenheit, 140 degrees Fahrenheit. Not livable conditions. So the researcher who led this study is Dr. Camilo Mora. She is a geographer at the University of Hawaii at Manoa, and she led the study. And she said, and I quote, "For heat waves, our options are now between bad or terrible. Many people around the world are already paying the ultimate price of heat waves. And while models suggest that this is likely to continue, it could be much worse if emissions are not considerably reduced." She goes on to state, the human body can only function within a narrow range of core body temperatures around 37 C, because heat waves pose a considerable risk to human life, as the high humidity and the high temperature raises body temperature, leading to life-threatening conditions. She is the one that also states that the Middle East could become uninhabitable in the very not too distant future. Her report can be found in Nature Climate Change, that journal there. Continuing with more climate news, Greenland. Let's shift our focus to Greenland. British and Belgian scientists think they understand why part of the Arctic is melting at a faster rate. In the journal Science Advances, they found that a drop in cloud cover and more summer sunshine means that more radiation, typically in the form of in the ultraviolet end of the spectrum, reaches the snow, delivers more energy, which results in increased melting. The lead researcher is Dr. Stefan Hofer. He is a doctoral student at the University of Bristol, located in the UK. He led the study. So they have measured basically a 1 to 3% decrease in cloud cover over Greenland, and this is leading to increased UV radiation reaching the ice sheets, delivering more heat energy, accelerating the melting. Because scientists have been surprised at the rate of melting in Greenland, and this now may be a mechanism to explain that. Continuing with the Arctic. The move to a warmer Arctic in the winter months is simply explained. There's a matching growth in stormy weather. What is meant by stormy weather and warm spells? In the Arctic, warm spells is when the thermometer is above minus 10 degrees C. Now, this has happened in the past, sure, but the time periods, the time frames of this occurring is much more frequent, and the durations last longer. So, researchers from Norway, the US, and German glaciologists report in the journal Geophysical Research Letters that for the last 3 winters, polar temperatures have risen to near freezing. Why is that? This is also related to the Arctic Ocean itself freezing later in the year. The southern extent of the ice formation does not extend as far. Basically, there is more open water. So when any sunlight energy, before the winter darkness sets in, any sunlight energy, instead of being reflected off the ice, what we call albedo, is now absorbed by the water. This is heat energy. It's now stored as heat energy. This heat energy is stored throughout the winter and is now released in the form of latent heat. The best way to explain latent heat energy, if you ever in the wintertime walk by an open pond or river and you see what looks like a fog on the surface, that's the latent heat that's stored in the water being released. Well, you release that heat, that's clouds, can lead to stormy weather, but it simply is heat being released, helping keep the Arctic warm. The lead scientist in this is Robert Graham, and he does his work at the Norwegian Polar Institute, located in Tromsø, Norway. Continuing with climate news here. Warmer climate raises extinction risk. Okay. Humans, through various practices such as overhunting, overfishing, land clearing, urbanization, have encroached on wildlife and led to increases in wildlife death and extinction rates and so on. Add in the effects of climate change and the situation now becomes exacerbated. Researcher David Tillman at the University of Minnesota has published a paper looking at the next 50 years as human impact on habitat increases. The world has lost half of its terrestrial mammalian megafauna. That is mammals heavier than 44 kilograms. Okay. 15% of all bird species. In a second paper, lead author Forrest Isbell, also the University of Minnesota, then discusses the benefits of conservation. Biodiversity in the form of trees and scrublands saves humans up to $3 trillion just as carbon storage alone. That is keeping carbon out of the atmosphere. Human activities are driving the sixth mass extinction in the history of life on Earth. Despite the fact that diversity of life enhances many benefits people obtain from nature. Wood from forests, livestock forage from grassland, just even plants that provide medicinal purposes, fish from oceans and streams. In other words, for our own survival, we must increase biodiversity. By the way, if you have not read, I highly recommend reading the book Sixth Extinction by Elizabeth Colbert. It is an excellent book outlining in great detail some of these issues here. That is all the time I have for this particular video. I will continue discussing climate news shortly in my next video. Thank you for watching. Please support this work.